We talk about entity, boundary, control. What are they? Are they entity class? Or are they boundary class? Or are they control class to you?
Boundary class?
Control class.
Control class. I mean, I'm talking about image and answer. What are they? Exactly. These are information we put in, information we get out. Boundary, right? That's how we interact with the system. Then, is there any entity class in this system?
Not necessarily.
Not necessarily. Do you think it makes sense to have entity class in this system?
I mean, in an actual machine learning system, there would, because you want to have a data set that it actually trains on. But if all we're doing is putting an image in and getting an answer out, and we don't care about recomputing that answer later, we don't necessarily need to store the image.
We'd also, yeah, we can, yes, we don't have to store the image. But do we need to keep other kind of information?
Store the answer?
What is other information you're storing?
It's a cat.
Exactly. That is actually called your neural network. You need to store your neural network inside. This is a neural network. What is a neural network? Basically connections. Right? You need to save that information. So you actually have entity class which actually save your neural net. Connections and weight of connections. So basically, you say the neural network is very simple. Do we have a relationship of some sort? How strong is that relationship? Right? So basically, that's it. So essentially, then it's trying to rush all the data through it and see they can come up with a best. So if I give you 10,000 image, okay, I'll give you a network which start with almost like nothing, right? Everybody connected, everybody have the same weight, right? Then the so-called training is I'm going to rush the 10,000 image through it and see how I adjust the weight to be able to differentiate all these image as much as I can. Okay? After that, I got the network connection like this and the weight of each connection. This is actually the training stage of your neural net. Then you need to put this neural net here. Otherwise, if you don't keep your neural net here, you wasted all your GPUs. Wasted, right? That's why you need an entity class called neural net to save this information. So you can use this information later on in so-called inference to decide if this image is a cat or not, right? So this is actually you need to save information called neural net. Then your control class is actually the action of inference. How you actually fit this image into this neural net, eventually you got off an answer. Okay? The neural net is just data. You need a program, basically. You need an algorithm which load in the data and actually use that to compute your image. That's computation going on. Here is actually you have a lot of multiply, addition here to process your image. Okay? That is our control class. So you have two kinds of data coming in. You have your, basically here, you have your entity class, which is part of, this is your weight coming in, and also probably your network structure coming in. And these two information all together, you compute your answer. Okay? So that's why we have entity class, we have control class, we have boundary class. Missing anything, any of them, you don't have a computing system. You don't have a program. Okay? All right, so we do have some notation for it. You don't have to remember this, just this is not something we're going to enforce you to use. All right, so how do we find entity classes? We need them because they save the permanent information in our system, our program. right? So we can do this. We can do functional modeling, present scenario of all use cases. We try to determine the entity class and their attributes and their relationship and their behavior. We'll walk through this. All right? Wow. Here I'm basically hitting you with a piece of English specification. Okay? Same thing like iPhone hit you with that chat app specification. Same thing. Okay? Happen to be this is something you also use not daily but often called the elevator. Some of you may say, oh, I'm really not lazy, so I don't take elevator at all. I'm basically walking up and down the stair. All right? But you still know how to run an elevator, right? So this is a description of elevator. This is definitely not the description of elevator. Otherwise, our elevator will be incredibly unsafe. This is just a mock example, right? So this is just like our chat app. We give you an English spec. Now we want you to make a program out of this. Okay? Well, that's going to be your job, right? Software programmer is to turn somebody's requirement into implementation, from English spec into Java code or C++ code, what have you, right? So if we have this, basically what you're doing is we're going to read this and trying to figure out use cases. All right? So since you guys already know this, so I'm not going to let you read it into detail. So here are, okay, we'll first come up with use cases, right? Basically for us, the elevator has two functionalities essentially. You push a button on the floor to call the elevator, and then you get in the elevator, push a button to go to a certain floor. Right? Any dispute? You may say, oh man, that elevator has a lot of fancy functionalities. Oh, let's forget about that for now. I mean, we would just say the most basic one just going to be, I call the elevator to the floor. For instance, over there, I call it to the ground floor. I get in the elevator, I push a button to go to 5th floor. I get out. Okay? So essentially, here, you can imagine I'm going to call for the elevator. I'm going to run the elevator to my floor. Okay? To do that, you can push an elevator button or you can push a floor button. Okay? So use case, that's a use case diagram, okay? So this is our use case diagram. Remember, a user. Is this me? Or you? Or you? Yeah, this actually represents all of us. Because we walk out this door, go to the elevator. To the elevator, we're just this, a user, right? No, nothing special about us. There's no differentiation about us. I mean, maybe in the future, okay, when AI becomes a real reality, when you walk out of the door to the elevator automatically open the door. You don't need to call the elevator, the elevator will show up. You walk in the elevator, if you think about the floor level, it will get to that floor level. That still take years to happen. So for now, okay, this is our simple model of elevator. Okay, to the elevator, we are just that user. Okay, this is our elevator system, and hey, there are just two buttons for us to work on. Certainly, this is going to be a set of buttons, but you can represent them by numbers. Right? Simple. So this is going to be our model. This is going to be our use cases. Okay? Remember, the goal of writing down use cases, even writing down requirement document, is so that once you are finishing up with your document, I can take your document, give it to her, and say, go work on elevator. And she should have no major difficulty going to the next stage, which is what we're talking about, analysis. She may come to you once in a while to ask clarification questions, but she shouldn't be come back to you 24 hours every day. Just have to get more information. That is not going to work, right? Nobody can work that way. All right? A use case provide a generic description of overall functionality, push a button to call elevator, push a button to go to certain floor. Very roughly, right? Okay, a scenario is an instant use case. So essentially, we need to study different scenarios to actually fully understand a use case. For instance, here. So this is a normal situation, right? No, so certainly when we call elevators, the things can go wrong. It's not always guaranteed to happen a certain way, right? So that's why when we program, we cannot just program our program to serve one single scenario when everything is right. We also need to account for situation when things go wrong, right? Normally, so everything happens. This is going to be our scenario. Okay? What if we have an exception scenario, right? Exception scenario. So for instance, timeout and that kind of thing could happen, right? You have to deal with that. It's all running the elevator, calling the elevator, running the elevator. It can be different. Okay? Different scenario, different use. I mean, the same use cases may have different scenarios. All right. So essentially here, to extract our classes, one way is that we can go study that use cases and run off all the scenarios, but that could be too much. Okay. So a simple way for us to do is actually to do this. Okay? Here, I'm not talking about the most efficient way, okay? You may be able to come to a conclusion much faster. Right? But here, just a way that's, okay, if your approach doesn't work, or you have no clue what to do, here's the approach. All right? It's called non-extraction. Okay? Here is when you say, oh, I don't have a way, I don't have a systematic way to identify classes. I don't have a systematic way to extract attributes. Okay? This is not the most, the smartest way of doing this, but this is the way, approach, I think it's pretty much going to work. So for instance, for the elevator problem, you can describe the key thing from the elevator problem. If you use the original description, it would work too, just a little bit more work, right? What you do is identify all the nouns. You may say, oh man, are we going back to elementary school now, right? That's why what I'm saying, this approach is the base, okay? Anything else fails, you can always chip this thing away with your chisel. Okay? This is when my gas mower stop working, I take a mechanical mower out and I still can do the job. I need to get a long mowed, but yeah, I don't have a most powerful tool now. I just use my mechanical one. Yeah, it's going to be pretty tiresome for me, but I can still get the job done. Right? So here, basically, we are going back to elementary school. All right? In this specification, we are looking for nouns because when we studied English, we know that if some information need to be saved, some information need to be permanent, some information need to be kept, most of the time they are represented by nouns in our passages. Right? Okay, so we'll identify all these nouns, separate them out, and go from there. well, this is, you may say, oh, this is a waste of time. I already know what to do. Yeah, in that case, you know, basically, yes, you are talking about you can run. Okay, but remember that none of us could start just running when we were born. We actually learn to crawl, then we walk, then we start running. Okay, so that at least a baby can move around by crawling, not very efficiently, but can be mobile. The same thing happened here. At least this is okay. When you run out of other way to do it, efficient way to do it, this way will give you some result. So here, we are not guaranteed to give you the most efficient way to work with identify entity classes, but this is the way for you to get your job done. All other classes you're going to take here, beyond this, are going to be learning shortcuts, accelerated way to deal with problems. Right? And here is a fundamental way of doing things. These are the nouns that you identified. Oh, great. So here, basically you have all the nouns. They are clearly overwhelming. If you have a class definition for them in your program is just going to be like crazily big. So essentially, we get all the nouns, then we filter them. Okay? Among these nouns, you are separating them into three kind of things. Number one, this is actually representing important information we need to keep in our system. For instance, buttons, elevator, floor, those are important information, right? However, there is other information that we just, for instance, movement may not be actually useful for us, right? Eventually we say, okay, actually the important thing are going to be elevator and buttons, right? So here, what we're trying to do is, these are all the candidates. We're not throwing them away, but we are going to pick from them. So these nouns are either going to be three things. They can be a class, they can be attributes of a class, or they are nothing. No other choices. There are only three choices for each noun. They either will be a class, or they are going to be an attribute of a class, or they are nothing. You don't have to worry about them. They're just filler in the passage. Okay, not having them will not change any meaning. Just that it may make your passage read better, but it's just not critical. Okay, so all the nouns in your requirement either going to be class name, class, or attributes of a class, or nothing. Okay? And you decide how to assign them. But don't throw them away, because you may back to say, oh, now I realize that should actually be an attribute, that should actually be a class, right? But you know all the information is here. You haven't lost any information. Make sense? All right. May sound boring, but this is, in software engineering right now, on 300 level, we now teach you how to run. We teach you how to walk. Okay? We just teach you, sometimes you can classify as a dumb approach, but you can get your job done. Okay? Then for other classes you learn, actually you are learning the optimization to make your job done fast. Okay? Here, we'll ensure you, if you are thrown a piece of specification, you can chip away the job, get the job done. You may take a lot of time, but you can get a job done. Right? With more experience and more learning, you actually can do this in an accelerated way and chip away things faster. Instead of using a mechanical mower, you actually use a powerful gas mower. Okay? So this is how we actually, a very simple but guaranteed to work way of get your classes identified. Okay? Because any nouns here either going to be a class, or attributes of a class, or they're nothing. So basically, when you say why this, you can decide that they're nothing. If you really remove that from your passage and feel that, okay, that's actually didn't affect anything, you know it's not important. This is how we actually learn how to analyze a piece of text in elementary school, in middle school. Same way. Same way. Right? Elementary school teacher and middle school teachers, they need to teach you how to understand a passage, a paragraph. Then essentially running through the same approach. Instead of just trying to understand, you are trying to understand here, but also not only understand, you are also going to define. Okay? There in elementary school, your goal is to understand that paragraph, that article. And here, not only you have to understand that article, which is our description of elevator, but you also need to define a parallel structure within the computer which mirror what the elevator is going to do. That's your job as a software engineer. Different from middle schooler. Right? You're using your life skill of being able to comprehend natural language text, convert that into structure that computer can handle. Okay? With that, you can define your class diagrams. Okay, your button class. Button class can have two subclass, elevator button or floor button, because they are all buttons. And you have an elevator class which representing an elevator, which have top to the buttons, elevator button and floor button. Okay? These are the information, because in our use case, we basically say push a floor button to push a elevator button to call for elevator, and push a floor button to drive the elevator to certain floor. Okay? You all have that here. Right? However, do we really need this? No. It's actually a syntactic sugar to make your hierarchy better and your code easier to manage. To be honest, this is not necessary. Okay? Because finally, in running programs,